Octopus, yes, good job, Lenovo. Whoever Lenovo is. And the last one, I find this picture very, very pretty. What do you see here? What are they? These beautiful pink, colorful structures in the sea. What are they? Yes, they're coral, absolutely. And we will be speaking more about corals very, very soon. So just hold on. Yes, and I'm sure now all of you know what this is. This is planet Earth. And the reason we've put a picture of a marble here is because there's so much resemblance, right? The Earth looks just like a tiny blue marble that we can see. And it's blue. Can you tell me why it's blue? It's blue because we have so much water on its surface. It's one of the few planets. Yes, it's because of the ocean that's there. And this ocean has so many plants, animals, microbes, which are very, very tiny plants and animals that you cannot see with your naked eye. And all this is present in our beautiful ocean. That's what we're going to be speaking about today. And I spoke about the beach earlier, right? So this is a beach which is actually very, very close to my hometown. And I used to love to go to this beach every weekend with my mom and dad and dig up the sand or bury my legs. So I'm sure, do you play in the sand as well? Do you go to the beach? Yes? I think that's a yes. We all love the ocean, right? Yes. Okay, so without any further ado, let's get started with our first and most exciting part of today, which is an Olympics of the ocean. Now, when I was a little girl, probably about your age, I was always wondering whether we could do like an Olympics for the ocean, which means I would think, what is the fastest animal of the sea? Or what is the smallest animal? And I would want to know which one is the biggest, or the ones that can like be in the hottest temperatures or can withstand the coldest temperatures. So that's what we're going to do very quickly, okay? So we're going to speak about the first. Which animal or animals came to the ocean the first when the earth just started getting life? So when we had life, and it began many, many millions of years ago, which was a very, very long time ago, we had life on earth which started in water. So water was very, very important for life to begin on earth. And these animals or plants, whatever they were very, very tiny. We couldn't see them. We probably would not have been able to see them with our naked eye. And so we needed to have a microscope. But now I want all of you to take a deep breath with me, okay? Let's inhale. What did we just inhale? Air, yes? But what's in the air? What's in the air? Yes, but do we have nitrogen in the air? Oxygen, yes, we have oxygen in the air. And do you like oxygen? Yes. Do I love oxygen? Yes. But the animals that lived so many years ago on Earth, the first little animals that came, they did not like oxygen. They did not want to be in a place where there was oxygen. That's strange, right? But later on Earth, we started getting lots of oxygen. It was just chemistry. There was lots of oxygen that started building up. And animals started adapting. They changed the ways they lived and they grew and survived. So that's why you and I can breathe oxygen and live with oxygen. Now we'll move on to the next interesting thing, which is the smallest. Now, when you jump into the ocean, or you just swim or snorkel or dive, what do you see? Do you see sand? Yes. Some rocks, maybe some fish? Yes. Some plants? Yeah, but do you see these? Yes, seaweed, yeah. But do you see what I'm showing you here? Probably not, because with your naked eye, you can't see these things. These are too small for us to see. And you need a microscope to be able to see these organisms. We call them microbes. Microbes. I'm typing them out for you here. That's what we call them. And these microbes are very, very important for the health of the ocean. And without them, life would not exist. Now we'll go on to the deepest. I've always wondered what could possibly live in the deepest parts of the ocean. But the first thing, before we do that, I want us to take a poll. Okay, I want you to tell me what is not present deep down in the ocean. What do you not see? Or what is not there? I'm waiting for your answers. Okay. It's very, very different deep down in the ocean. So, what's different? What's not there? We have about half of you who voted already. That's great. The answers are still coming in. Yes, I'm waiting for all of you. Come on, let me see what you all think. There's no right or wrong answer. There are many answers, but I'll tell you the one that's for sure. Okay, great. So can you see what is not present in the ocean? Well, most of you thought there's no sunlight, which is exactly what I was hoping you'll tell me. There is no sunlight. And when there is sunlight in the ocean, animals and plants, they take the sun and they make food, right? Yes. But in the deep ocean, when there's no sun, what would they do? But some of you said there's one person who said there's no heat, which is also true. There's no fish is a bit debatable. I think we do have different kinds of fish there. So now let me show you something. These two men, in 1930, this was about at least 90 years ago. So they took a deep dive into the ocean. They built this little sphere that you see here, and they went down 800 feet, which was quite deep. And subsequently, they did many, many dives. And these two men, they became the first ever to go deep into the ocean. Now, what was special about this was what they saw in the deep ocean completely changed the way they thought about the ocean. They saw animals that looked completely different, maybe even monstrous. They had different adaptations, which means they changed the way they lived. Now, do you know what this fish is? If you've seen the movie Finding Nemo, you might know what this fish is. It's called an anglerfish. I'm typing it out for you here. It's called an anglerfish. And what's really amazing about it is can you see the little light type, a fleshy structure like an antenna on its head? Now, what that does is it uses the light that is there to attract prey. Prey are things that the anglerfish can eat. So whatever it likes to eat, it will shine this like flashy light and it'll swim around, and then other little fish or anything else that it finds is interesting would come near it and it will eat it. So that's what it does. And it's present very, very deep in the ocean. Now, I want you to take a guess and type in the chat box how big do you think this anglerfish is? Is it A, 10 centimeters, B, 30 centimeters, or C, 100 centimeters? I'll give you just like a minute or so to like tell me what you think? Oh, we're getting like mixed. We're getting a very good range of answers. Some of you think 10, 30, and 100. Uh-huh. We have a lot of seas as well. So many of you do think it's quite big. So yes, it is very, very big. At least compared, even when I looked at the answer, I thought, wow, it's as big as 3 feet. So yes, their size does change, but the largest possible size that it could get to is about 100 centimeters. So it's between a 30 and 100 centimeters. Okay, so let's move on. Now so we have the oldest. So we're going to speak about which animal could be the one that possibly lives the longest in the ocean. So I have a little poll again for you. So I want you to type the answers on your chat box. You have 1, which is an octopus, 2, a turtle. We have a seahorse for 3, and 4 is a starfish. Which animal among these 4 do you think lives the longest, lives many, many years? We have 2 of you who think, okay, most of you think it's a turtle. So we all seem to think it's a turtle. Yes. So the turtles do live to be very, very old, but their age actually is largely a secret. No one really knows how old or how, like, the oldest a turtle can possibly get. And these turtles are beautiful creatures. The turtle mothers, they swim large distances. They travel very, very long distance to reach beaches where the mother will dig up in the sand and she will lay her eggs on the sand, after which she will bury the sand up so that she keeps the eggs very, very safe. And when she thinks it's the right time, she will swim back into the ocean and come back when her next batch of eggs are ready. That's what they do. But the cool thing about them is they would swim very long distances to find the best beach and the safest possible place to hatch their eggs, to lay their eggs. So now we're speaking about the fastest. I've always wondered what is the fastest, and there's no one answer to this. Of course, there's not a single answer to a lot of things that I'm speaking about. I'm just talking about a few that you could, learn about today. So today I'm going to be speaking about something different. What do you see here? Can you type what you see here? What is this? It's a shrimp. And this is not just any shrimp. It's called a snapping shrimp. And I'm sure many of you, when you see a shrimp, some of these kind of shrimp, you could have heard like a snap sound when you go very close, right? Like sometimes it could be very, very loud. Why don't you all try to do this? Can you all snap your fingers and see how loud you can possibly get? Yeah. Yeah. So you know what these snapping shrimp do? They rub their claws together so fast that the water that's just around their claws tend to boil because of the heat that gets generated. And that heat gives a sound which is as loud as a snap from our fingers, which is why they're considered to be some of the fastest creatures in the ocean. They also use this to stun their prey, as in to shock the prey that they get, so then they could eat them. Okay, so now we'll move on to the oldest, or the coldest. And remember I said I used to wonder what could possibly live in Antarctica. It's so cold. There's so much ice, or even in the water when it's so cold. So you'll be amazed to know that these animals, these are sea otters, and they can withstand extremely cold temperatures. It's because their bodies are like furnaces. They are, when we say metabolic furnaces, it means they generate so much heat inside the body that they can stay warm for a very, very long period of time. But there's one thing that they have to do to keep staying this warm. What do you think that is? What should an otter do to keep staying warm? Does it have to keep swimming? Does it have to eat? Or what does it have to do? It has to eat, eat, and eat. Yes, it needs to eat. Yes, it does need to have fur. But the most important thing for the otter is it needs to keep eating to get energy, that it needs to generate this kind of heat within itself. It eats about half its body weight. So if you weigh 30 kilos, you need to eat about 15 kilos of food in one day, like every day. That's how much the otter eats. Okay, so now let's speak about the best mothers. I'm sure all of you have the best mothers and the best fathers in the world. But today we're going to speak about the best mothers and the fathers in the ocean. And the best mother in the ocean is, well, I'm going to ask you to guess. What do you think this is? I'm waiting for you to tell me what you think in the chat box. It's not a squid. I'm giving you a clue. It's not a squid. Yes, you're right. It's an octopus. Yes. And it's not just any octopus. It's a blue ringed octopus. Can you see those blue rings in the picture? I'm not sure if it's clear, but there are tiny blue rings on its, can you see it? Yeah. And this blue ringed octopus is considered to be very dangerous in the water, because the minute you go near it, it tends to spray out this ink on you. You go psh on your face, because it's scared actually. So the octopus is saying, don't come near me. That's why it's like spraying that ink at you. And scuba divers would ideally move away so they don't get too close to this. This is usually about this big. It's not very big in size. But yeah, it's not just the blue-ringed octopus, but octopuses in general are very, very good mothers in the ocean. Now, let's speak about fathers, yes? We have Father's Day that's coming, right? So we have to speak about fathers. So can you guess, the best dad in the ocean could be the seahorse. Yeah, and I found it quite surprising when I learned about it. But seahorses are one of the few animals, not just in the ocean, but even on land, that practice male pregnancy, which means the fathers will get pregnant and they carry the babies, not the mothers. In most other animals, it's the mothers that carry the babies, but only in seahorses and a few other animals that live in the sea and that live in the ocean, the dads are the ones that carry the babies. Interesting, right? Okay, so this brings us to the end of the first part of our session, which was an Olympics of the session. I mean, Olympics of the ocean. Did we all have fun so far? Are we all okay? Yes? Yay? Okay, great. So can we move on to the next one, which is the greatest survivors of the ocean? Let's go ahead. Okay, yeah. All right, so now we're going to speak about something that I like a lot. And these are, can you guess what it is again? What am I showing you? Yes, they're corals. And I love corals because that's what I studied when I first got into this field in marine biology. And so corals, okay, but before we start all this, I have two questions to ask you. The first is a coral a plant or an animal? What do you think? Is it a plant or an animal? Okay, I say one person says animal. What about the others? You all think they're animals? Okay. Planimal. Well, yes, they are animals. they're definitely animals. They're not plants. So well done. I think all of you are already experts in this field, and you don't need me here at all now. So now we will, oh yes. So the second question I have is a poll. And I want to ask you this. Do you think corals appeared on Earth before the dinosaurs or after the dinosaurs? Yeah, you guys know so much. Most of you think it's before. Then yes, you are right. Sorry, yeah. Most of you think it's before, and yes, you're right. They did appear before the dinosaurs, and they continued to stay through the extinctions that the dinosaurs went through. So that's what's cool about these corals. They are very, very good survivors that have survived several mass extinction events, which means mass die-off events that the Earth went through. Now I think I'm going to share some facts about corals that I've always spoken to kids about or adults, and I think that's what I want to share with you as well. So the first thing is, it's the largest living structure that you can see from the moon or when you go to space. So which means you can't see anything else that's natural. The only thing that you can see is the Great Barrier Reef and the coral reefs there. Isn't that fascinating? And there's another thing that's very impressive about these corals, because remember I said they are animals, right? And they developed something that was very, very important in the animal kingdom. They developed a gut, a stomach with a digestive system where they could get food in, digest it, and get energy from the food. And they were successful when they developed this feature. And when they did that, it passed on through the rest of the animal kingdom. So if you and I have stomachs today, a mouth and the gut, you know whom we need to say thank you to? We need to say thank you to these corals because they did it first. But there's also something which is quite, not, I wouldn't say scary, but interesting about the corals, that they fight for space and for food. So now I'm going to play you a little video where I'll show you what I mean, where corals tend to fight. The coral that is on the left is called a brain coral. And the coral on the right is actually using its tentacles. It's stretching these arms out and it's actually eating up the coral because it wants to use the space of the brain coral. So it's moving and it's saying, move away, I want to use this space. It's the same here. The same coral, Hydrophora, is attacking an Acropora on the left, using its tentacles. Can you see those white tentacles? Yeah. So they can also be carnivores. They fight for space and food, just like many other animals that we know about. Now, the next survivor that I think is worth talking about is the horseshoe crab. How many of you have seen a horseshoe crab on the beach? I'll put my hand up this way. Yes? How many of you have touched a horseshoe crab? Yes? No? They don't do anything to you, but you could just turn them over and touch them. But these horseshoe crabs, no one really knows actually how long they've been around, but they've been around for ages, and which is why they are considered to be incredible survivors. You can see them on the beach, so I think it's much more accessible than even the corals. So if you do go to a beach, then definitely do go and take a look at these beautiful creatures. But I have an interesting fact for you. Do you think the horseshoe crab is related to a crab or a spider? Since I said it's an interesting fact, it's already a clue, right? You can type out what you think. Is it related? Like, is it close? Yes, it is related to a spider. So it isn't that isn't that interesting? It's not related to the crab family, but it's related to the spider family. All right. So we're done with two sections, the Olympics of the ocean and the survivors of the ocean. Now we're going to speak about what threats the ocean is facing. There are some extremes that the future holds for the ocean, and so that's what we'll be speaking about in the next couple of minutes. Okay, are you with me? Are you all happy? Ready? Yes. Okay. So this picture, what do you see in this picture? I see a boat. I see two boys. What else do you see? You can type out whatever you see in the chat box. You see trash, junk, yes. And see, what's interesting is the first responses that I see here, none of you say water. You all say trash, rubbish, or junk. Because all you can see is that, right? You can't even see the water that's underneath. We have so much litter, marine litter, that reaches the oceans every year. And 90% of this is carried by just 10 rivers in the whole world. So the 10 rivers carry most of the marine litter and dump them in the ocean. And 8 of these rivers are in Asia. 8 of these rivers are in Asia. So by living in Asia, we have this huge responsibility and also awareness for us to be involved in this global crisis. And it's amazing that you're all listening and working on it and paying attention to this on a very, very special day, which is Oceans Day. Now, this is what I tell everybody. We are all speaking about plastic and trash in the ocean, right? So we speak of what we see is when we go to some restaurants, sometimes they say they don't give us straws, they don't give us plastic spoons. Even we have stopped using plastic bags, which is all extremely good. It's wonderful. These are initiatives that will definitely help in the years to come. But there's one other thing that we're not speaking about, and this is sewage. Sewage is wastewater that comes when you flush, when you use the bathroom. How many of you have thought about where the water goes after you use the bathroom? Have you? Well, I didn't until like very recently, until a couple of years ago when I started studying about it. Yes, we would probably think it just goes down a pipe. But to where? It all ends up in the ocean. All the wastewater goes right there. Sometimes it goes through a treatment plant where they put different chemicals in it and they make the wastewater, they improve the quality of the water before they push it into the ocean. But in most countries, they don't do anything to it. They don't treat the water and they dump it straight into the ocean. Now, this is a huge problem because sewage is rich in some nutrients. We call those nitrogen and phosphorus. So sewage is, I'm writing it for you here. Sewage is rich in nitrogen and phosphorus. And when some animals see like lots of nitrogen and phosphorus coming in, what they do is they start gobbling up these, whatever comes from the wastewater. And when they do this, they start growing in size. So there are some algae, like some seaweed, that start eating it up and they become bigger and bigger. And they don't have place, they don't give room for other animals to live. And when they start breathing all the oxygen in the ocean stops having enough oxygen for all the other animals to live. So when you have too much sewage in the ocean tends to become choked for breath or like starved for oxygen. And this is not a good thing. Now, another example of what happens when there is sewage, or when the water quality around the ocean is not good. It could even be temperature, if it's too hot. Because of global warming. I'm sure many of you have heard about this term, where things are all getting warmer and warmer every year. The picture that you see here is a beautiful red sea fan coral, which is on the left-hand side, and a staghorn coral, sorry, on the left-hand side. And the right-hand side is the same staghorn coral, which is bleached. And bleached as in it's turned white. And do you know why it's turned white? Does anybody know? It's turned white because corals tend to have very small microbes in them, on their skin, on their surface. And when it gets too hot, or when they don't like the water, the quality of the water, these little microbes that are living on the coral would swim away. They would leave the coral, and the coral that's so beautiful and standing will not have these algae anymore, these microbes. So the corals would turn white because it's the algae that live in the corals that give them the color. And yes, they do die if they're left white for a very long time. The corals die. But if they turn white and we change the conditions of the water, then they could come back, and the coral color will come back and it'll be fine. So those were the threats. So you now know about marine pollution. You know about two big types of pollution that I spoke about today. The first is plastic pollution. And the second extreme that I spoke about was sewage pollution. And I also spoke to you about what happens when you have these kinds of pollution in the ocean. Yeah? So now, what can we do about this? What can you do? What can I do? So to get started with that, I will speak about what scientists are doing first, what researchers are doing. And most of us are working on education. We work on measuring ocean life, and we work on restoring ocean life. So if there's a problem, we work on how to make that better. Like these bleached corals, we could make them come back to life, or we have new coral nubbins that we plant, things of that sort. So to get started, I will speak about what I do in my field of work. And the first thing that I do is before I get started on exactly this mini ocean condominium, I want you all to know that on land, there are many, many scientists who've studied different parts of the land, and most of the life on land we know. So we know them even when they're microbes. We've already understood them and we've documented them, which means we've built a library of all their like DNA. So we know what lives. But in the ocean, even today, about 60 to 70% of life, we still don't know. We don't know their names. We can't see them with our naked eye. And they're also invisible. So we don't know what lives. But the ocean is dealing with all these issues. We have so many kinds of pollution to deal with. So the first thing we need to do to help the ocean is to not just go into it, and we need to figure out what lives there before we figure out how to help those animals that live in the ocean. Yes? Yeah. So to do this, the first thing that I do is I put these blocks, they're about this big. They have layers in them, and I call them mini ocean hotels because I leave them, I scuba dive and leave them in the ocean for a year or 2 years. And after which I collect, I dive again maybe a year or two later, and I bring them back up in this little bucket. I'm not sure if you can see. There's a little white bucket by the coral reef. So I put a bucket on top of this hotel because in that 1 or 2 years, many, many animals would have crawled and sat inside because they think it's a hotel, right? They like to make it their little home. So I would then bring it up to the surface, after which I would study whatever has colonized the place. So we've in the past done this in Hong Kong, in Hawaii, and we're doing it in India. And we're seeing many, many kinds of animals. And what I do is we get kids like you to come and work with us so that you can touch and feel all these animals. And we identify their names. So I would say sea urchin, and I would find out the scientific name of the sea urchin so that we build a library of life in that part of the ocean for generations to come. Now, the next thing I've also been doing is I look at how healthy the ocean is. And to do this, there are different ways to study the ocean. There's no best solution. There are many solutions. So the first video that I'm going to share with you is I look at how much food can seaweed or algae make and how efficient they are in making this food using sunlight and nutrients in the water around them. So in these plastic bottles that I'm pulling up, I put some algae inside, and I came back 2 days later to check how much the algae have grown. So if they've grown a lot, it means the ocean is healthy. But if they've grown too much, it means maybe there's something that's out of balance. So there's always a perfect threshold as to how much we need them to grow for the ocean to be considered healthy. Now this video I'm going to show you is also, I like it a lot because it's very short. Now the steel rod that you see here is a steel rod. And what you see here that looks like a cotton ball, it's white and it's round, is dried squid. And I'll tell you why it's there. Now, in a healthy ocean, you need to have animals of different sizes. You can't have an ocean that has only microbes or only sharks or only plants. It doesn't work that way. The best oceans are also the ones that look the prettiest, which means you have animals that are very small, small plants, small fish that eat the plants, big fish that eat the small fish, and even bigger fish that eat the slightly bigger fish. You understand? So it's like a food web that grows from a very tiny animal to a very, very large animal. And we need to have all of them for the ocean to be healthy. So what I did is I deployed this steel rod with a piece of squid. I put it in the ocean. That's what I mean by deploy. And I wait for tiny fish to swim and come and eat the squid. And if they eat the squid, it's a good sign. It means we have fish that like to eat animals like the squid in the ocean. It means we have slightly bigger fish available and it's not as polluted. So there you go. You see this, you see a couple of fish that are coming by and checking out the squid. They're saying, can I eat this? That's what this fish is wondering. So here, this is another video of something else that I'm measuring. On this slide, you'll see to the right side at the bottom, I've put a picture of 2 tea bags. There's a green tea bag and rooibos tea bag. I'm not sure if many of you drink tea, but so, I mean, I guess your parents drink tea. Do you drink tea? I guess. So what we did is I put these tea bags in the ocean. I did a scuba dive and then I buried them in the sand. You'll see that happening in the video. I'm here with my friend Tehun, who also studied in the same university that I did. And we're burying these tea bags in a reusable plastic bottle. And we will leave those tea bags in the sand for a long time. After which I usually come back after 3 months and I check how much of the tea leaves are still there. And this is because I want to see how fast these animals are eating up stuff in the ocean. So these are called decomposers. They live on land as well, in the soil. And it's very, very important for them to function properly because they deal with all the trash, all the dead animals that die and settle down on the seafloor. they are broken down by these decomposers that are buried in the sand. So I wanted to see how effectively or how well they're able to eat up everything that I give them. And this experiment went quite well. So the last part of what I want to speak about is, what can we do? What can you do? What could you speak to your parents about, your grandmother and grandfather about, your teachers, your friends? What can we do to save the earth and our oceans? Well, I have two simple things here. The first thing is, you can use plastic bottles repeatedly, many, many times. And this is just a picture of some plastic bottles that have been used to grow plants. And it's not just this. I think our co-hosts would also share a link with some of you to use this resource that I came across about ways to use plastic bottles. And these, I found them quite interesting to be used for activities for children in class or even at home, to use old bottles or anything that's plastic and come up with something that can be used in our daily life. And another small thing that I thought of is when I go to an ice cream parlor, I used to, sometimes maybe ask for a cup. And then it has come to me recently that maybe we should all be eating ice cream only in a cone, because it saves so much plastic. No cups, no spoons, and you eat it all up, right? So next time you see anyone eating ice cream in a cup, tell them to eat ice cream in a cone. Yeah? Okay. Now, before we close this session, I have a little song and dance that I want to share with you. So I hope you can all see the words here. Yeah. Now this song is called What Can You See Under the Sea? So the first time I'm going to sing the song with the music, and I'll show you the steps. And the second time, you can follow it with me even now, but the second time I want all of you to dance with me. Okay? Yes? Okay, I'm excited. Let's check if the volume is up. Yes, it's up.
What can you see under the sea? What can you see under the sea? I can see a whale, I can see a squid, I can see a seahorse, I can see a jellyfish. I can see a whale, I can see a squid, I can see a seahorse, I can see a jellyfish. Yeah. What can you see under the sea? What can you see under the sea? I can see a crab, I can see a dolphin, I can see a shark, I can see a starfish. I can see a crab, I can see a dolphin, I can see a shark, I can see a starfish. Yay!
That was amazing. Can we all do it together? You can move, you can stand, you can sit. Yes? Yay! Okay. So let's all do this. Are you all ready? Hi. Hi. Okay, let's do this. Ready? Go.
What can you can you see under the sea? I can see a whale, I can see a squid, I can see a seahorse, I can see a jellyfish. I can see a whale, I can see a squid, I can see a seahorse, I can see a jellyfish. What can you see under the sea? What can you see under the sea? I can see a crab, I can see a dolphin, I can see a shark, I can see a starfish. I can see a crab, I can see a dolphin, I can see a shark, I can see a starfish. Yay!
Yay! That was amazing. So with that, I think we've come to the end of our session, and I'd let the co-hosts take over. You're welcome to ask any questions that you have for me as well.
Yeah, thank you very much, Archana. Yeah, it's a great session. It's very interesting and very engaging. I enjoyed a lot, and I've learned a lot also. So now let's see if you have any questions that you want to ask Archana here directly. You can either just raise your hand and then we will allow you to talk, or you can type in the chat box or the Q&A box.
I see a question on how old is the bleached coral? How long until it can grow back?
Yes,
I don't know exactly how old it could be, but I'm guessing it'll be between about 50 to 60 years old. This one died, so it didn't come back. But what we do, to make this a story of hope on this special day, what we do is we make coral nubbins. So when we go to some sites which are undergoing bleaching, we look for a healthy coral and then we take bits of its arms, we come back to the surface and we use little cement structures, like it could even be a plastic structure. So we glue those arms to those structures. We're technically making small babies from like a big mother coral. And then we go back to the ocean and plant them in the same habitat. And when we come back regularly to check, usually they grow. So if we lose one, we try, at least in the habitats that we have some access and permits, to grow as much as we can. I hope I answered your question. Do we have any more questions?